Welcome back, everybody. For this section, we talk about caves, caverns, and sinkholes. So first, what is the difference between these three? Well, Earth, for reasons we'll talk about in a bit, has these large cavities, holes underground. And if one of these cavities is big enough to where a part of it is never going to get sunlight, then that is called a cave. Now, some of these caves are going to form in conditions of dissolution, dissolving, and they can grow stalactites or stalagmites, these things called speleotherms. These are going to be caverns, right? Finally, you can have cases where the ground has been weakened above one of these holes, above a cavity, above a cave, to the point where the ground actually collapses in. And that intersection of the ground, of the hole, right, the hole in the ground surface, is called a sinkhole. Okay, but before we can talk about caves, we have to talk about limestone. So limestone looks like this. Naturally, it might be cut into blocks. It's one of the main ingredients of cement and of concrete. This is what the pyramids were built out of. Calcium, carbon, and oxygen all put together. And importantly, if you take something that is made out of limestone and you expose it to slightly acidic rainwater, it'll start to dissolve, right? The rainwater starts to eat away at the limestone. Okay, so let's make some caves here. Most caves on Earth are going to be formed through dissolution, right? Think dissolution of limestone. So we take some rock body, which is exposed to slightly acidic water, either through rain or through water in the ground, and the water actually starts to eat away at the rock over time, forming these cavities. An example of this that we've all seen is what happens whenever you take sugar or salt and you put it into water. Well, over time, it looks like the sugar or the salt starts to disappear into the water, right? The water starts to disintegrate it, breaks it down into these particles called ions, and then holds it between the water molecules. So, in this example, what happened to the sugar whenever it gets dissolved? Well, it doesn't disappear from existence. Instead, it's still bound up as little particles in between the water molecules. So there are other ways that caves can form, but here's what we're going to think about to start our mental model. We have a big chunk of limestone, which is exposed to the surface. Limestone is soluble. Whenever it is exposed to water, maybe it's in a particularly wet area, it'll begin to dissolve and the water will eat away, forming these cavities inside the limestone. And in sum total, an area like this would be called a karst. You would call this karst topography. So we might think about this process in different stages. So our first stage, we have very limited cavities in the ground. Now, whenever it rains, that rainwater is going to mix with carbon dioxide in the air and in the soil to form carbonic acid, which comes down here and starts to dissolve away the rock. Over time, still precipitating, still raining, it's going to get deeper and deeper into the ground, carve out these bigger and bigger holes. Now, after it stops raining, the water table comes back down, but the cavities are left behind. And as this water begins to evaporate, it leaves behind the ions, the minerals that are trapped in it, and starts to grow these speleotherms, the stalagmites and the stalactites within the cave system. Now, so far we focused on limestone, right? Every cave is formed in limestone. Well, that's not completely true. It's going to be any sort of mineral or rock body that can be dissolved by water, including some of the cousins of limestone, things like dolostone, magnesium embedded in the crystal lattice. You can have other varieties of limestone, travertine, chalk, coquina. You can also have other minerals like halite, rock salt, or gypsum, which is like sheetrock. These will all dissolve and potentially form these cave or karst systems. So formally speaking, what is this karst topography? You can have a complex landscape characterized by many small, closed basins, bowls, sinkholes, cave openings, and disrupted drainage patterns. Why disrupted drainage patterns? Because the water is literally eating through the rock, so it's going to be much more complicated than water that just flows down a river. Usually, these are going to be found in regions that are underlain by carbonates, things like limestones, marbles, and things that are similar to these. So this is one example of a sinkhole here, except it's not really a sinkhole. Why? Well, because it was caused by people. It's not naturally formed. It was actually caused by leaky pipes. So whenever the pipes leak, the water comes down and leaches away at this stuff in the ground. And as a result, you have this enormous sinkhole, big cavity that opens up as a result, doing massive damage to this part of the city. It's actually, I believe, in Guatemala City about 10 years ago. But one of the cases where poor planning, poor construction results in just tremendous damage to the city. Now, we actually do have a cave system here in Arizona, something called Caverns. You might be familiar. Going to be located about 50 miles southeast of Tucson. Now, these were discovered about 50 years ago and actually kept secret for a long time, not open to the public until later. Maybe that's a mistake, maybe not, but now we can go there, so it has to be a plus for us. These formations, these stalagmites and the stalactites in Caverns have been growing for tens of thousands of years, and you can actually walk around for a considerable distance, up to 2.5 miles of passageways here. So this is a map of what Caverns actually look like. Okay, we have our scale bar down here, so from here to here is about 100 meters. Means that some of these rooms are actually going to be very, very large. I mean, something like this being 50 meters, 150 feet across, is going to be a sizable room here. And we can look, we have our different tour trails, places that a person could walk on, but as you'll notice, a lot of it is actually closed off from the public, closed off so as to be protected from any sort of interference by human beings. So, before we can talk about the caverns themselves, we have to talk about the time when those rocks were originally laid down, a time called the Carboniferous Period. It's going to be about 300 to 350 million years ago. We are in the age of amphibians, right? You have no dinosaurs, but we have this sort of well-established terrestrial life, animals. A lot of these would have been amphibians. We also have huge bugs, one of the characteristic, memorable things about the period. Seas are dominated by sharks, and you have these fun little guys called crinoids, which actually stand on the bottom of the ocean, stand up, and feed that way. You have dense forests all over the world, along with a lot of swamps. These swamps lead to the formation of coal, and that is why you have the name Carboniferous here. And the very end of the period is about the time when Pangea forms. Alright, so with that in mind, we can look at our formation timeline. So back in the Carboniferous, 300 million or so years ago, we have the original deposition of that sediment. Now, we skip a lot of time here, and in the meantime, we would have had deposition of new rocks. A lot of time passes, a lot of deposition. Our next big event is going to be basin and range faulting, right? Extensional faulting. It's going to help bring things to the surface and uplift them. And as a result of bringing these rocks to the surface, they are now exposed to water. Exposed to the water table, and they begin to dissolve and to form these speleothems. And actually, it would be a good question. 5 bonus points to anybody who can tell me how anybody knows that a speleothem, right, the stalagmite or the stalactite, is 200,000 years old. How is this date established? And since then, a lot of the history can be discovered from looking at animals or animal remains which have been found in the cave. You have a sloth entering about 80,000 years ago. You can find bats using the cave about 50,000 to 40,000 years ago. And slowly, as the area dries out and gets more arid, moving into the present, the speleothems start to slow down, not grow as fast until we get to modern-day desert, at which point it is no longer growing in the same way that it would have before. There's just not as much water. So this map has all of the different cave systems or karst systems in the United States. And what's going on with the colors? So red is volcanic, which is more of a pseudo-karst than a real karst, but you can have lava tubes and other sorts of cave-like structures that form there. The yellow is going to be formation of a karst system in some sort of unconsolidated sediment, loose sediment. Blues are evaporites, halite, gypsum, and the greens are going to be carbonates. So what do we notice? Well, right away, most of it is going to be carbonate systems, and the one place that you're going to have more caves than any other is going to be down here in Florida. As far as the distribution, it's something that is relatively widespread, but also rare, right? You see these pop up all over the place, but generally, Florida and a couple of areas aside, the areas covered tend to be pretty small, okay? For the final section, we talk about water use and scarcity. What happens when there's not enough water?